Hello. This video is about the construction of a small, relatively simple part which I made with FreeCAD. It's a part that I'm using on an antenna construction, and as you can see it here in the picture, lower left of the screen, this part is there to hold a coaxial cable in a specific position on the end of a tube. It's a 20 millimeters diameter plastic tube with 1 millimeter of wall thickness. It's a sort of a tube that you have for electrical installation isolations and protection of cables, sort of this stuff. And the antenna is built of two of these, which are mounted perpendicular. A few days ago I made a video about the center holding piece that keeps both the tubes in a perpendicular way. And now I want to show you how I constructed the plugs that I'm putting on the end of the tube, and where I can put the coax cable in and then fix it with either cable binders or straps, or with isolation tape or whatever you like. That's not something that really has to do with FreeCAD. That's just because people have been asking me what I'm doing, and seems like others are also ham operators. Okay, so before I start with the video, I would like to thank all of these who have sent me a couple of dollars to buy me a beer. I'm very grateful, very thankful that every now and then somebody gives me $5, $10, $15, something the like, and I enjoy drinking the beer. Obviously, I'm not to say you had to wait so long for the next video. No. This took a while because I was occupied with a lot of other things, and in the moment it looks as I have some more time for these videos. Good. So let's start with the construction. As usual, first I will show you which version of FreeCAD. I'm working with FreeCAD 0.18 in this case. It's a revision 4. That's from the autumn of last year. There have been a lot of things going on with 0.19, but those things that have been going on from my point of view, and that's my personal point of view, have not much to do with what FreeCAD beginners need and want. And I recommend to stay with the 0.18 until the day where 19 has gone out of all these smaller glitches, and it will just be the standard. So in the moment I stick with 0.18 for the videos and also for most of my work. Good. So the next thing, as usual, I'm working with something specifically in the way that the mouse is moved, and if we go to the preferences, we can see what I'm talking about. It's the way how the mouse is being moved on the display, and that's the gesture 3D navigation. So if you follow my videos piece by piece and you want to repeat the steps which I'm talking about, you probably use the gesture mode. Good, so that's enough forward. I recommend before you start looking at this video, you probably look at one or two of my other videos to get a little glance of the real ground laying beginning stuff. Okay, we switch the workbench, and as I'm usually, view workbench part design. We're gonna start this, we're gonna do this in part design. As we should know, we need a new document, and in the new document at least we need one body. The body is the container for at least one sketch, which we select here, and we have to put this sketch on a plane. So the construction has an orientation in the 3D space. We click OK, and we get our working window. In the other videos I'm describing all those icons and stuff like that. Today in this video I will also only describe the ones that we are specifically using for the construction. This time what I'm gonna do is, first I will draw a very rough sketch how this thing is gonna look like when we cut it through. So if we look at this thing from the side, first what we see will be a cylinder, and that's a cylinder seen from the side. And if we imagine we have cut this cylinder, inside the cylinder we will have three cavities, three cylindrical cavities. The reason why we have these cavities is we need these cavities to put the walls of the tube in. So this will be more or less concentrical rings, and this is going to be an inner ring just to save filament. You can see for some unknown reasons these constrained elements have a black background. I don't know why this happens. This must have something to do with the way of my video recording software. So they will, in your case, they should not have this black background. Good. So then next step is we will put this into a defined size. And I'm defining the size not by entering the overall length and so on. No, I'm going to define it differently. What is the most important thing in this case is the distance between these 2 points and the distance between here and the outer and here, between the inner hole and or the inner cavity and the cavity for the wall. So these two obviously must be same size, so we give this an equality constraint, and both must be on the same horizontal level. That's also, oops, sorry, they are horizontal, so we need to put these points on a horizontal level. I'm not going to do this with this one because this one can go up a bit more to even save more of material. Good. So then we need a center line, and the center line I'm going to put in now. And as you may see, the lines are white. This would mean if we save this and we create some feature from that, then these lines would try to create a feature. That's not very good. Normally, most of the times I've shown a master sketch, which is a sketch on its own containing all these values. This time it's gonna be a little bit different because this time we're gonna make a master sketch which integrates the drafting. You will see what I mean later. Okay, so that is the center line, and we just leave the center line where it is. Okay, let's say this point to this point is a distance of 10 millimeters, whatever. Now we have a ballpark figure of size, and we can stretch these things a little bit and also move them on our liking. So now first is these 2 points should be symmetrically to this line. So I selected both points, I select the line, and I make a symmetric constraint. This point and that point should also be symmetrical to this line, so we choose them and we make them symmetrically. So now when I move them, you can see it's beginning to be constrained somehow. So we say this is somewhere above, and we want to have a distance from here, which is the thickness of the top of our plug, and we want to make this let's say 3 millimeters. Now we move these down, and we want to have a distance here which is another 3 millimeters. So then we need a wall thickness so that the plastic wall goes in here, and the wall is 1 millimeter, but I found out 1 millimeter is not enough because 3D prints always have the tendency to be a little bit tight on insides. So let's give this 1.2 millimeters of distance. That turned out to be the right value. So next is, we know that the outer distance or the outer diameter of our plastic wall is 20 millimeters, and therefore I want to constrain the distance between these 2 points to 20 millimeters. 20 millimeters. And now we can still move these up. We put both on this line, so they're fixed. And next is we have to fix this one, also fix this point on this line. Let the center line look down a little bit. Again 10 millimeters. And as these two 10 millimeter values are not of interest for the basic construction, they're just to fix the line, we can do the following. We select both of them, and then there is an icon which is called the selected constraints to the view of the virtual space. If I click this, these values hide away, but they're still here. I can switch the virtual and the normal space, so the possibility is there to hide constraints which we really don't need for the actual construction. So fine. Now what else do we need? Okay, we need to have this hole symmetrically to here, and we need a distance from the outside to the wall, and I want to make this again 3 millimeters. 3 millimeters on a 3D print is quite stiff, relatively stiff. So finally we need the height of the whole thing, and let's give this a height of 25 millimeters. So we still have 3 degrees of freedom. Well, 1 degree of freedom is the whole movability. So we finally have to lock this to some place. Move the constraint values a little bit out so they don't look so clubbered. Here, 20 here. And next thing is we double click these to give them names. So we call this length. We call this 20 millimeter constraint diameter tube, and yeah, this one still needs a constraint, so we want to have another 3 millimeters here as the thickness inside, 3 millimeters, and we name these 3 millimeters wall inner. We name these 3 millimeters wall outer. So these we also need later on, and we call this top thickness or thick, and this is second top thickness, whatever. As long as this tells you what you want, it's good. And this one finally we name tube wall slot. Good. So let's put this here, and we click one of the points, and then we create a lock constraint which finally fixes all of the stuff here somewhere. You can, if you like, say, okay, I want to have this on 65 and I want to have this double clicked on 14. Doesn't really matter. And to unclutter, we move them to the vertical space again. Good. So that's the first part of this construction. Now let's construct the actual piece as it is. And therefore, first we need to do the following. We select all the elements that we have constructed up to now, and we change them to be help line or construction lines, which are now blue, which means they are not really used for the actual 3D part. And in this case, we can just start to put in a real 3D part. We switch to the problem mode, which is the black line mode, the real line mode. We create a circle. Check that the circle doesn't move. That's good. Change the size only. Good. So we need to define the diameter or the radius of this circle. Always take care, radius, diameter. That can confuse from time to time, because here we have a length of 20 millimeters and that is diameter, not radius. We switch to constraint diameter, and we key in an equal sign that brings the formula editor, and we key in constraints diameter tube, and there we add 2 times constraints wall outer. So this brings 26 millimeters of diameter for the whole. We close, and now we can create our first pad, and we give this a height of equal sketch constraints length. Okay. So that is the first piece. Now create a second sketch. and we create this second sketch again on the XY plane. And so that this existing pad doesn't clobber our site, we go back to the model, we click it once, and with the space bar we can hide it, or we could give it a transparency, which I already selected before, but this doesn't help us in this moment, so we have to really make it invisible. There is a possibility I will show you. There is one additional function here on this icons, which is section and full view, and the section view will only show you what's below your construction axis, but sometimes this is not really what you need, so the better thing is to switch the pad off. Good, we make sure we are in standard line mode, and we create one circle, and that one circle needs its own diameter. So we constrain diameter equal sign, and from sketch dot constraints we take the tube diameter, and from the tube diameter we have to take away 2 times sketch constraints wall inner. That brings us 14 millimeters. We close the sketch and we create a pocket. To see this pocket, we first have to switch to reversed, because the pocket normally tries to go downward into the plane, and we have to reverse it so it goes upward the plane. And now we have a length equal sketch constraints length, and from this length we have to subtract sketch constraints top thickness. Okay, so now the inner cavity just goes up until it ends 3 millimeters before the top. This was the first pocket, and now we need the second pocket. Again, XY plane sketch. This time let's take this mode, and you will probably find this somewhere else on your screen. Look for this blue icon with the red circle in front. Here it's limited space to have the videos not so big on YouTube. This 1400 by 900, that's a quite nice compromise, and that's also when I create them on one of the laptops. That's the screen size of my little laptop. Good, so let's continue. We need 2 new circles, roughly here, roughly here. So the diameter of the outer circle, that is simple sketch dot constraints diameter of the tube, and the inner one will be equal sign sketch, equal sign sketch constraints diameter tube minus sketch constraints tube wall slot, but this time we need this multiplied by 2 because it's once here and once here. So that should bring us the proper diameter, which in this case is 17.6 to 20, and that is 2.4, meaning 2 times 1.2, so that's correct. Fine. Now the cavity itself, again reversed, and again equal sign, sketch length constraints length minus sketch constraints top thickness minus sketch constraints second top thickness. Okay. You may wonder why I did this with 2 different lengths. That makes it more stiff. It creates a thicker structure here, and I found out that this makes a little bit of a difference later on. Good, so let us save our work. You will first give it a name. I already named it Cable Fix Free. Good, so that's this part, and now what we need is I want to create an arc, and along the arc I want to create a sweep of a profile that holds the coax cable. So first we need the sketch for the arc, and here we can see the planes, and we can either take the XZ or the YZ plane. Let's take the XZ plane and create a helping line. Switch to be a helping line in blue, and this line is gonna be symmetric to our center line, and the length of this line is defined in sketch dot constraints tube diameter plus 2 times sketch constraints wall outer. That should bring us exactly the 26 millimeters. And the position of the line can be fixed as a vertical constraint, again retrieved from sketch constraints length. Once you are common with this way of working with the formula editor, it is relatively convenient, and you can also from time to time overthink your construction and find out mistakes earlier than you would if you just do by visual things and by constraining. So as we now have the construction points that we need, the next step is we create an arc. Therefore we use the arc symbol, and we start with a point that is a line on the vertical axis, and we just drag it over here. Now let's start constraining. Definitely both these points have to be on the same horizontal axis, and it will be much flatter and then we have to define how far it should go outwards here. And in real life it showed up that the distance here should be a bit more than the distance here. So we give that a name and say outer dia, and then we say this distance, sorry, wrong click, this distance equals constraints outer dia plus 2 times 15 millimeter. As we can see, it tells us in compatible units. Be sure you have to key in the measurement unit, in this case 15 millimeters. So now we have that here, and next step is we define that these, or one of these points, is on this line with a point on line or point on object constraint, and we still have to define how much this bends through. And I would say we could start with, let's say, 10 millimeters below the whole object. It would be possible to construct this by drawing lines and so on, but I found out that this 10 millimeters below is a relatively good value. So we just close this, and in the moment nothing happens with this arc. What we do is we need a few points now, or not few points, we need a point, and that's the end point of the arc, as well as that we need a so-called construction plane, a datum plane by its real name. And let's create the datum plane. So it wants this last selected sketch, selecting this line, and we need to find out or define how it should be in space, and that's a normal to the edge. So normal to the edge means that the edge, which is the arc, goes out of the datum plane perpendicularly, and that's what we need for our sweep later on. We click OK, and we need another point, and that's a point directly here on the plane, the end point of this arc. So we select the arc, we click on point, click it, and the point that we want is called on edge. We see it a little bit difficult here when, let's switch back and forth. So it's on edge, which means this is the edge of the arc. Well, it sounds a bit strange, but it is. Okay, so now we have what we need. We select the datum plane, we create a sketch, which is now on the datum plane, and I usually, before I do a long construction, finding out afterwards it doesn't work, I just create a simple object, and then I try my feature definition, which in this case is, I select sketch 004, I choose sweep a selected sketch along a path, then we need the edge where we sweep along, and that's our arc. And we can already see it does work. It creates our sweep. And now, time to make the sweep complete. Sketch 004, we can double click, go back and hide the datum plane, hide the datum point, and start working on it. So what I want is, I need an arc which looks similar to that one. I want these 2 points on horizontal same height, similar to here, also same height, and this also same height. Then we create a line from here to here, one from here to here. Let's see if that works. Oh, no, we didn't get it. Okay, constrain coincident. That's good now. So if we tell this line and this line is equal, we automatically should get a symmetry. There's a missing constraint. So we're symmetrically already. And I want to define that this distance here equals 4.5. That's a bit more tight, 4.2 millimeters. And the radius of, or the diameter of this one, that should be 5.2 millimeters. That's the size of the coax cable I want to press into here later on. Okay, so that looks relatively good. What else do we need? I want an overlap with the original part of, let's try 2 millimeters. We can change that later on to probably fit better. And all we need is the final size, and that can be defined if we define a horizontal length here. Let's start with 3 millimeters, and there we also need some height, and well, let's go for 8 millimeters. We close the sketch and we see it already looks relatively good. What we have here is there a gap or is there no gap? Doesn't seem like that there is a gap left over, so that should be working pretty well when we finally print this. Good. So that was all for the basic construction. Now we take the additive pipe, we change view, workbench, mesh design, meshes, create mesh from shape, standard, OK. So if we switch the pipe off here, what's left over is the meshed pipe. And now we need to check if that one is correctly calculated by analyze mesh, evaluate and repair mesh. So let's do an analyze of the mesh, and it looks pretty well. Everything is good. Sometimes meshes with overlaps, with things that protrude into each other and so on, they can easily have double points or they can easily have self-intersections, and that can be corrected somehow in this function. But this time we were lucky, nothing happened. Okay, so everything is complete now, and we go to export the mesh. I call this one capfix 1. Save it and open my slicer program. And what we do is we open an existing project. So I gotta go to my 3D model folder, and I take a ABS print setup, and then I open my 3D file and put it in here. Now finally what's to do is, if I print this as it is, what would happen? Let's do this. When we slice it and we look to models and paths, we can see, number one, here we have a raft, which would probably be needed because you start to print from the bottom up to here. Now, usually the upper levels of a 3D object let's reset the view. The upper parts look better than the base parts where you scratch off or where you take away your support structure, your raft and all these things. But in this case it's not very good. Why? If we look down into we could see that there are structures being printed inside here, like this support material. Luckily it wouldn't print the support material here, so it would probably work out. This one can be taken out and there's nothing in here, just some movements, but this won't be any material. So it could probably happen to work. If you have a model that looks like that, most times it'll fill the gap with support structures, and then it's not so easy to scratch these or to take these out of a very thin gap here. So what I would do is transform mesh, flip upside down, slice again, and now it will fill here, which gives a more rough surface on this side, but that doesn't matter, that isn't from interest. And here we have no infill for sure. So I printed it in this way, and you saw how it looked after the print in the FreeCAD file. So that was it. I hope you learned something. I hope it was fun for you. Look forward to my next videos, and as usual, again, thank you for those who have already sent me a tip. So if you liked that video and would encourage me to do some more, buy me a beer, use the PayPal address. Every little donation is welcome. Bye for next time.